Public participation in urban biodiversity and green zones. This module introduces terms and concepts related to the topic of urban biodiversity and green zones. Different use of cases of participatory methods for biodiversity planning, expansion, and conservation in urban contexts are also discussed. Participatory approaches and methods for biodiversity work in urban environments are illustrated. Within this module, you will become familiar with introductory terms and concepts related to the topic of urban biodiversity and green zones. You'll get acquainted with different use cases of participatory methods for biodiversity conservation in urban contexts, and explore how different participatory approaches and methods work in practice for biodiversity conservation in urban environments, and how results can be achieved with such methods. To help you further develop your understanding of the topic, we have created breakpoint activities to guide your learning and provided additional resources worth exploring. Please familiarize yourself with the module structure. In Section 1, we'll explore terms and concepts related to the topic of urban biodiversity and green zones. Our planet is filled with a variety of life forms and ecosystems. All these are known as biodiversity. An estimated 8 to 10 million species, varieties of life forms, populate our planet. These include varieties of animals, plants, fungi, and microorganisms. These life forms are all around us, including our cities. In addition to species biodiversity, the Convention on Biological Diversity recognizes genetic and ecosystem diversity. Genetic diversity is the variety of different genes in plants, animals, fungi, and microorganisms. Genetic variation is critical to enable species to adapt to changing environments. Ecosystem diversity refers to the variety of dynamic complexes of living organisms and communities and their non-living environments interacting as a functional unit. There are unique ecosystem dynamics in various habitats such as forests, deserts, grasslands, tundra, freshwater, and marine ecosystems. Biodiversity is under threat. Today's rate of biodiversity loss constitutes the sixth major species extinction event in the history of life on Earth. And this time it is driven specifically by human activities and impact. Urbanization and over-encroachment of natural areas is one factor that contributes to this extinction event. Supporting urban population health and livelihood also places pressures on resources and areas around and outside of cities. While cities can negatively impact biodiversity, they can also be places where biodiversity is enhanced and conserved. Why should we care about biodiversity loss? Life forms on Earth are interconnected through the food chain and symbiotic relationships. Damage to some species can result in harm to others. As this damage increases and expands, more and more life forms and ecosystems are lost. As we humans are deeply dependent on the biological system for our survival, loss of biodiversity can eventually threaten the well-being of our own species. From a land use perspective, cities are an efficient solution to housing large numbers of people. To date, more than 3% of the Earth's landmass is urbanized, while housing 55% of the world's human population. This is expected to increase to 68% of the human population by 2050, with a similar ratio of population to urban land coverage. Nonetheless, cities can negatively impact biodiversity, and this impact can be either direct or indirect. Cities can have a direct negative impact on biodiversity in several ways. Biodiversity can be adversely impacted by encroachment into natural habitats, causing loss or fragmentation of habitats. Humans can also introduce into cities invasive or harmful species or chemicals and pesticides that may threaten local species and ecosystems. Indirect negative impacts can also be significant. As consumption centers of biological and mineral resources, cities can lead to large-scale habitat change and species overuse. Demand for food, particularly meat production, consumed increasingly in cities, leads to massive deforestation in the tropics and subtropics to clear land for production of animal fodder. Our demand for buildings, transportation vehicles, and energy infrastructure leads to large-scale mining outside of cities, leading to large-scale land use change and habitat loss for many species. Cities support a high proportion of Earth's species biodiversity. Many of them are even native to the region. World's 20% of bird species live in urban areas. 70% of these species are native to the region. Urban areas host 5% of the world's vascular plant species, out of which 94% of the species are native. Some cities can have remarkable diversity in life forms. Cape Town, South Africa hosts 50% of the country's critically endangered vegetation types and about 3,000 indigenous vascular plant species. Brussels houses more than 50% of the flora of Belgium. Singapore has recorded 390 species of birds and at least 2,100 native vascular plants. Rough estimation of biodiversity in Yerevan suggests that there's as many as 2,000 species of animal, plants, and fungi in this city alone. The iNaturalist website alone reports about 520 species reported from Yerevan at the start of the year 2021. The value of biodiversity can be described in more detail by the ecosystem services it provides. The benefits or services can be categorized into 4 types: supporting, provisioning, cultural, and regulating services. For example, urban green space improve the local climate by combating the heat island effect, cooling the air through evapotranspiration. Through this process, energy consumption is also reduced, contributing to energy efficiency. Plants are also great for pollutant absorption and dispersion, reducing urban air pollution and positively impacting human health. Furthermore, green spaces have cognitive and psychological advantages. Besides encouraging physical exercise, exposure to nature lowers drug and painkiller consumption and even speeds up post-surgery recovery. It allows for relaxation and social unity. The recent trend of rooftop gardens and community gardens is tackling the challenge of food deserts, places where there is shortage of affordable, healthy foods, while also reducing the carbon footprint of food production and transportation. Biodiversity can be found almost everywhere, in wetlands and rivers, parks and gardens and green areas, streets, rooftops, walls, and even sanitation facilities such as refuse disposal sites or wastewater treatment facilities. Through proper planning and design, these areas can support and enhance biodiversity and help eliminate or manage threats to it. A variety of species inhabit these urban areas, including native species, or species that are indigenous to a given region or ecosystem, exotic species, or species that inhabit areas where they are not native, invasive species, or species that displace native organisms and transform the urban ecosystems, and of course domestic species such as pets. Now let's briefly walk through some concepts. Cities have many elements that can hinder or promote biodiversity. Among these are transportation, power, solid waste, and wastewater infrastructure. Street landscaping, if designed and planned properly, can offer important continuity to habitats of various species while improving comfort and air quality. These streetscapes can enhance and help conservation of biodiversity by creating green corridors for wildlife, preventing soil erosion, and conserving water. Parks, the most common form of green space in cities, come in different sizes, shapes, and styles. Some parks even have a function outside of recreation and leisure. After Valencia's river Turia was diverted to prevent flooding, the dry riverbed was developed into a 5-mile-long park. It encourages waterside walking, has soccer fields, fountains, Zen gardens, and bike paths. Sydney Park Wetlands is an artificial wetlands as a result of Sydney's water reuse systems. The wetlands were developed on a dumping site and now hosts native wildlife, bike paths, waterfalls, and stepping stones. Parks like Sydney Park Wetlands are becoming more common across the world. Biodiversity can also be hosted on roofs and walls. A green roof is a roof of a building that is partially or completely covered with vegetation. Green roofs can support succulent, herbaceous vegetation, and even shrubs and trees. A green wall is made of plants grown in a supported vertical system. Green walls can be on external or internal structures. Green walls and roofs can enhance and conserve biodiversity by providing food and shelter for animals. Urban agriculture is defined as any form of agricultural production occurring within or around cities. It entails cultivating, processing, and distributing food in and around urban areas. Urban agriculture can happen in back or front yards, rooftops, community gardens, and public or private plots. Urban agriculture also involves forage activities or harvesting fruits, nuts, and edible greens from public spaces, also referred to as food forests or edible landscapes. Urban beekeeping and animal husbandry can also take place in cities. These activities can also create food and habitat for animals and also directly increase species diversity in urban zones. Natural landscapes such as gorges, hillsides, and catchment areas can provide natural habitats for wildlife in urban areas if left undeveloped or properly developed. These landscapes are unique opportunities for conservation and green development. Rewilding is a form of ecological restoration in urban areas where humans step back and leave an area to nature. Rewilding is done without use of herbicides, pesticides, or irrigation. There are a growing number of rewilding efforts, from High Line in New York, once abandoned elevated railway adapted into a public park with native grasses that support wildflowers, trees, and shrubs, to the Wild Mile, which aims to transform the man-made North Branch Canal of the Chicago River into a haven for wildlife, creating habitat for biodiversity, areas for recreation, and education. Since 2015, the City of Dublin has been allowing native wildflowers and weeds to flourish in parks, open spaces, roadsides, and even graveyards, creating a habitat and food for insects, bees, and pollinators. The presence of all types of species is not always desired. Invasive species are often not native and lack predators that control their population. Invasive species compete with native species, can damage crops and infrastructure, and even harm health and quality of life. Invasive species are often considered to be the second greatest threat to global biodiversity after habitat loss. Urban areas are at a great risk of invasive species invasion due to accidental arrivals in ports, airports, and transport hubs. There are interesting solutions to invasive species, one of which entails eating them. In the United States, there are examples of invasivore cook-offs and from problem to plate programs that combat invasive species by cooking and dining. One of our case studies will discuss another less delicious approach to fighting invasive species. Soil health and the biodiversity it contains is crucial for humans and ecosystems alike. Healthy soils provide the food we eat, the water we drink, and even the air we breathe. Unfortunately, cities seal soil under structures, which is one of the main drivers of loss of biodiversity due to impact on health of soil. Designing greener cities can positively impact soil health and the biodiversity that comes with it. Pesticide use has a harmful impact on biological diversity. It can have short-term toxic effects on directly exposed organisms, including beneficial organisms, as well as long-term effects on the ecosystem. While the largest use of pesticide is in agricultural areas, urban areas can also impact biodiversity through the use of pesticides. Equally important, pesticides can harm humans and their domesticated animals. More and more citizens are opposing the use of pesticides in parks and streets where they live and their children play. In the EU, municipalities have formed the Pesticide-Free Towns Network. The members work to eliminate pesticide use, replacing it with sustainable and natural alternatives. The network also exchanges knowledge and experience. For additional information, visit the link. When building roads, canals, buildings, and the like, humans fragment wildlife habitats. This fragmentation can reduce the chances of survival of various animal and plant species. Moreover, in the case of many animals crossing roads, they face the risk of being killed by moving vehicles. The built environment can be modified to make it more hospitable to wildlife, countering both habitat fragmentation and killing on the roads. Example of modification could include building wildlife bridges, tunnels, corridors, passageways, nest platforms, and so on. Bird glass collisions are a serious threat to birds. An estimated 400 million to 1 billion deaths occur in the United States alone and around 25 million bird deaths in Canada annually. As birds cannot recognize the daylight reflection on glass, glass does not appear solid to them and often leads to flying birds crashing into windows and being injured or dying. There are many ways to make glass and windows bird-friendly or bird-safe. Bird-safe glass is designed to make glass a visible obstacle to birds by removing glass reflection or adding visible markers. External insect screens can also be used to eliminate reflection and prevent collisions. With bird-friendly glass, hundreds of millions of birds can be protected. For ideas on how to prevent such collisions, we encourage you to visit the website noted on this slide. There are tools available to city planners and policymakers for managing urban biodiversity, including enabling its enhancement and conservation. Municipalities will need to be guided by local factors such as legislation, budget, and the like to decide which of these tools or approaches are best suited for them. In many of these, public participatory tools are employed at various stages of urban biodiversity management. They're used in the planning, implementation, maintenance, and monitoring. For a compilation of biodiversity management tools, visit the Urban Biodiversity Hub website, ubhub.org. To illustrate these tools, two are briefly highlighted in the next slides: Local Biodiversity Strategy and Action Plan, LSBAP, and the City Biodiversity Index, also known as the Singapore Index. Local Biodiversity Strategy and Action Plan is a guiding strategy complemented by specific actions and adopted by local governments to achieve optimal and realistic governance and management of biodiversity and ecosystem services. An LBSAP typically includes a biodiversity assessment, including species and habitats count and distribution, their conservation status, priorities and targets, and finally budgets, timelines, and responsibilities. The preparation of the LBSAP should be a consultative process, and the relevant stakeholders' interests, roles, and responsibilities should be determined as part of the process. LBSAP offers great opportunities for public participation at every stage. The City Biodiversity Index, also known as the Singapore Index. The Singapore Index, a complementary tool to the Local Biodiversity Strategy and Action Plan discussed in the previous slide, is a self-assessment tool for cities to evaluate and monitor their biodiversity conservation progress. The index has 23 indicators within 3 categories. These categories are native biodiversity, ecosystem services provided by biodiversity, and governance and management of biodiversity. The scoring of the Singapore Index is quantitative. Each indicator is assigned a scoring range between 0 and 4 points, with a total possible maximum of 92 points. The first year the index is compiled is taken as the baseline year. Future applications of the index can chart progress in conserving biodiversity. Breakpoint. Explore. 1. Mentally explore your city and identify places of biodiversity. Can you recall any green roofs, walls, natural landscapes, or parks that support biodiversity? 2. Think of an area in your city ideal for a rewilding project. Describe the area and what benefits can be obtained from rewilding in that particular space. 3. What are some opportunities and challenges to green infrastructure in your cities? 4. Explore these interesting resources. In Section 2, we'll get acquainted with different use cases of participatory methods for biodiversity conservation in urban contexts. To involve citizens and local organizations in restoration and conservation of urban biodiversity, urban planners and managers can adopt participatory approaches from the onset of the development projects. The types of participation in urban biodiversity conservation projects could be broadly categorized into 4 groups. The first type of participation is collective monitoring of vulnerable species for more well-informed planning. The benefits of incorporating the public in this case are the access to more and hard-to-capture data, the increased accountability, and possibility to develop early alert systems. The second type is democratic decision-making concerning the allocation of limited resources to biodiversity issues. The benefits include the facilitation of having consensus over key decisions, the resulting efficiency of execution of key decisions, and the cultivation of a sense of responsibility among the public. The third type is the involvement of stakeholders to generate solutions and action plans for a given biodiversity challenge. This can also help citizens take part and responsibility for implementation of the solutions. The benefits of incorporating the public in this case are the opportunity to develop more diverse and inclusive solutions and the positive externalities in the form of social innovation and bottom-up initiatives. The fourth type is the involvement of stakeholders in sharing the knowledge about the value of urban biodiversity, the potential social or beneficial benefits of it, and the local challenges or threats hindering the materialization of these benefits. In module number 1, we had presented specific tools and methods that are used to engage stakeholders in planning and designing of complex systems. Some of the mentioned methods and tools, such as participatory sensing, public participation GIS, crowd mapping, open surveying, and data collaboratives, were more research-oriented in the sense that they helped reveal, understand, and monitor systemic challenges. Others, such as co-creation workshops, hackathons, serious gaming, were more solution-oriented and could be used to come up with solutions and execute them collaboratively. As cities are highly complex systems that require planning and thoughtful design, participatory methods are particularly relevant to urban planning and management. These tools can be chosen and used to involve the public in projects aimed at tackling biodiversity challenges. We will now take a look at several case studies that illustrate how the tools were applied in this context. Breakpoint. 1. Recall the urban biodiversity challenges that were discussed at the beginning of the module. 2. Which are the challenges that would become easier to tackle if the public got involved? Choose the top 3. 3. What could the public do to help address these challenges? Create a list of actions. In Section 3, we'll see how different participatory approaches and methods work in practice for biodiversity conservation in urban contexts, and we'll discuss the results that can be achieved with such methods. The case of Milwaukee, a city in the U.S. state of Wisconsin, provides an interesting example of public involvement for the creation of a detailed restoration plan for the Menominee Valley. Menominee Valley is a place along a river that was both invisible and inaccessible for people for decades. From the perspective of the river and wildlife, it was also a place that was mistreated for 160 years. A linear pocket of 25 acres of land bordering on one side of the urban Menominee River was its last natural stretch before confinement downstream by sheet pile walls, and on the other side by the railroad. Spotting a need for strengthening both urban and ecological qualities of the landscape, the Redevelopment Authority of the City of Milwaukee decided to create a restoration plan. In 2011, a project team was formed consisting of several public and private organizations, including landscape architecture and engineering consultancies, local schools and research institutions, and the municipality and regional governance organizations. The team decided to focus on the opportunity that the 25 acres, 2 miles from the heart of downtown Milwaukee, would provide for the creation of a significant wild place in the valley. The goal was to plan how to transform the irreversibly altered land and hydrologic conditions to a mosaic of biodiverse landscapes, including forest, prairie, and ephemeral wetland, native to Milwaukee and ecologically appropriate for new conditions. To do this, they decided to use some participatory methods and create the ecological restoration plan with systemic and meaningful community engagement. Before getting started with the community engagement, the team set 4 pillars or guiding principles for the plan to be co-created. The first point was to incorporate the fundamental ecological goals of recovering ecosystem integrity, health, and the potential for long-term sustainability to foster successional trajectories toward long-term biotic goals. The second goal was to provide for deep, universally inclusive environmental education that engaged all senses. The third goal was to maximize biodiversity at both habitat and species level. And the fourth goal was to enable individual discovery in a landscape that provided clues to a deeper understanding and heightened awareness. The project team started with the establishment of the Urban Ecology Center, an environmental education and citizen science facility located in Milwaukee. Their intention was to use the facility to bring together people from local neighborhoods, train them, and work on the creation of the plan together. The team then did an analysis of the adjoining neighborhoods. The analysis revealed the presence of numerous schools within the 2-mile radius of the site. This indicated that it would be feasible for students to have after-school visits to the center and work hand-in-hand with the researchers. In the subsequent stages, at the Urban Ecology Center, the team of researchers organized workshops for school kids, some parents who volunteered to take part in the project with their kids, and several other people from the community. Some of these people were contracted to work as, quote, part-time scientists, unquote. After the training, the team of researchers and citizen scientists embarked on the field research journey. They collaboratively implemented a natural history analysis of sun patterns with topographic aspects, and analysis of biotic conditions within the existing riparian forest. Trained citizen scientists helped collect pictorial data of the reference sites. The combination of the pictorial and quantitative analysis from reference sites effectively communicated to contractors the goals of microgradients and slope variability. This gave critical information for adequate planning. Besides, the researchers created tactile scaled models that allowed experiential mimicry and interaction with the dramatic topography to inform the design process and gather stakeholder perceptions. Such collaborative prototyping and testing helped get critical insights for the development of project management, labor allocation, and further communication aspects of the restoration plan. The co-created restoration plan enumerated trajectories to establish prairie, oak savanna, and eventual forests as long-term goals. It described innovative methods to achieve uncompacted soil structure and microtopographic variability. The plan gave thorough descriptions of 9 community types with 479 native species, which were viable, ecologically available, and manageable. Reference sites and their floristic quality helped give long-term guideposts. Novel native plant assemblages were used in the flashy river-influenced and stormwater-influenced areas to respond to those conditions effectively. Considerations were made for wildlife food and habitat through the seasons, especially the need of migrating birds, endangered reptiles known to be on the site, and amphibians, which were a mainstay of the riparian corridor. Provision for layered, textured, variable, recognizable species and patterns was made to enrich the interaction of people and landscape. The plan incorporated flexibility, phasing, and a blending of contracted and community labor. Responsibilities for the land manager were identified. The structure of a stewardship resource plan was discussed, with opportunities for the Urban Ecology Center programming to develop its restoration framework. The plan embedded a wild and healthy place along a still resilient river in the city, accessible only by walking or biking, big enough to surround one with nature, and without design structures. So in addition to ecology and those factors that influence the potential ecology, the co-created plan envisioned, analyzed, and communicated the practical needs of bringing new land into the public domain and developing truly participatory restoration in conjunction with a key educational facility, and of restoring and managing the land over time with limited and unpredictable budgets. The case of the Colombian city of Medellin also provides a successful example of adoption of participatory approaches, specifically open voting and co-creation, for executing a large-scale urban ecosystem services project. As a result of rapid urbanization and 50-year-long intensive urban development, the city of Medellin started to experience an increase in population density and urban mobility that caused extensive greenhouse gas emissions in the city. The urban heat island effect started to be observed, and the average city temperatures started to increase. This threatened cities' biodiversity. To tackle the issue and prevent potential disruptions in the provisioning of ecosystem services, the municipality launched a call for projects aimed at reversing the effects and hindering further aggravation of the situation. To select the project and fund it, the municipality decided to use the city's participatory budget that the Colombian legislation had dedicated for citizen projects selected through open voting. The project that got a popular mandate from the citizenry was a project called the Interconnected Green Corridors. The proposal was to train citizens from disadvantaged backgrounds to become city gardeners and to create extensive urban green spaces. As a result, 75 citizens from disadvantaged backgrounds were trained by Medellin's Joaquin Antonio Uribe Botanical Garden. Oriental Avenue, one of the city's most polluted streets with more than 1 million people passing through daily, was targeted as one of the first green corridors. The rationale was that the more polluted the area, the greater the potential environmental returns, meaning that including these avenues in the green, interconnected biodiverse network would reap great rewards for general city life. From 2016 to 2019, Medellin's citizen gardeners co-created 30 green corridors, Corredores Verdes, an interconnected network of greenery across the city. The gardeners planted 8,800 trees and palms in the 30 corridors that covered 65 hectares. In one of the city's busier thoroughfares, 596 palms and trees had been planted, as well as more than 90,000 species of lesser plants. These green corridors provided Medellin with a host of ecosystem services. A bioclimatic study estimated that in just one corridor, the new vegetation growth would absorb 160,000 kilograms of carbon dioxide per year for the initial phase of the plant's lives. This enabled carbon uptake via plant growth, helped capture particulate matter, PM2.5, and improved air quality. 3 years after the program's beginning, Medellin's urban heat island effect had reduced by 2 degrees Celsius. The Green Corridors project demonstrated how integrated nature-based policies like widespread urban tree planting could have a far-reaching impact on the local and global environment, as well as significantly improve citizens' lives and well-being. The initiative added to and connected existing green spaces helped create more wildlife-friendly habitats, which substantially improved urban biodiversity. From 2016 to 2019, around $16 million from the participatory budget was invested in the project. Breakpoint. 1. Think about an area in your city or its immediate vicinity that you think is underutilized or undervalued in terms of the ecosystem services that it provides. 2. Analyze the neighborhood of the area, such as what type of organizations are there in the vicinity, who are the residents, what else is located around it, and so on. List all stakeholders. 3. List the benefits that each stakeholder could get if the area was restored, and the activities that each of them could do to help in restoration. 4. Remembering some of the participatory methods that were discussed, think of ways to involve these stakeholders in a restoration project. Another case illustrating applications of participatory approaches, such as participatory sensing, co-design workshops, and open data initiatives for urban biodiversity, is a project implemented by Edinburgh's Living Lab. Smart sensors can recognize what is taking place in the environment. An array of multiple sensors can work out spatially where a sound comes from. In particular area, audio data can allow us to identify species of birds present, bat activity, volume of traffic, car accidents, and more. The University of Edinburgh's Living Lab, with its Internet of Things IoT initiative, specializes in researching innovative ways to use Internet-connected devices and sensors, such as temperature sensors, motion sensors, water gauges, and so on. They do this to understand and devise new approaches to improve the availability of ecosystem services across Edinburgh. Within the scope of the project, from 1st of November 2017 to 16th of April 2018, the Living Lab ran the Edinburgh City Sounds project. The project was designed to explore and celebrate the richness of sounds in the city, benefiting from recent innovations in digital technology and networking infrastructure. It focused on how sounds captured in the central urban green space can inform community groups and citizens about biodiversity and health and well-being, as well as provide a unique resource for artists and data scientists to come up with innovative social, commercial, or research initiatives. The project team adopted an approach focusing on involving the most relevant stakeholders from the outset. Organizing an initial management kickoff meeting, the team brought together the University of Edinburgh, the council, and a few representatives from other local expert organizations to share knowledge and insights about biodiversity in the meadows, health and well-being, digital audio art, data science, and to create project execution roadmap. First, the management team made the plan for installation of audio capture devices in the meadows. They shared knowledge about the specifics of the meadows, the devices, the feasibility of installation, and create a preliminary plan. Second, the management team discussed the long-term environmental and social goals and impacts of the project. They brainstormed and generated ideas about possible ways to engage the public by informing them about possible uses of the sound data, making data available to them, and inspiring them to use the captured data to come up with open innovation projects addressing the goals. The team decided to organize 2 co-designed data literacy workshops for public engagement. The first workshop aimed at training and inspiring the knowledgeable stakeholders, such as data scientists, sound artists, and local organizations specializing in biodiversity conservation, about the uses of the captured data, biodiversity monitoring, and so on. The second workshop aimed at informing and educating the broader public about the project, as well as teaching them basic data literacy skills. The management team also ideated on questions such as, what particular issues should the workshop address? How can these apply in general to biodiversity monitoring? How can they apply to the green network across the city that Edinburgh Living Landscapes is creating? How can Edinburgh Living Landscape and other interested partners use acoustic data to create evidence and evaluate the impact of their work? Can the monitoring help identify green tunnels through the city? In addition to the workshops, the management decided to organize a final sonic art exhibition open to the public to let the public experience the captured data and see some of the created innovations. After the meeting, the research team did a site survey in the meadows to refine and confirm the plan of the installation of the audio capture devices and creation of the necessary infrastructure. As a result, 6 audio monitoring devices created at the Edinburgh Living Labs were installed in the meadows. Each of them recorded 10-second samples in rotation, focusing on biodiversity in the meadows. The devices operated 24/7 and picked up birds, bats that couldn't be heard by the human ear, rain, traffic noise, and so on. The devices detected bird sounds within a 50 to 100 meter range and bats within a 30 meter range. Experts also installed a Wi-Fi access point on the 6th floor of the university main library facing the meadows. This allowed data to be directly transferred via Wi-Fi to a server. In addition, this made it easier for small biodiversity organizations to access the collected audio data, ensuring that organizations with little or no resources take advantage of this opportunity. The workshops took place at the University of Edinburgh Informatics Forum. 3 special guests who discussed their experience and projects with audio capture devices were Kate Jones from University College London, Simon Chappell, and Jonathan Silvertown. Kate Jones presented the Nature Smart Cities project, which presented an excellent example of learning about nature in the city through sounds. Simon Chappell then shared the vision of the City Sounds project and encouraged the participants to begin imagining all the things that could be relevant through audio data. Jonathan Silvertown sparked the participants' imaginations to the possibilities of all the different creatures that are roaming around the cities and that could be studied through IoT and other technologically advanced forms of biodiversity monitoring. He showed the participants the National Biodiversity Network's Atlas of Scotland, which kept a record of all the creatures that have been recorded in a particular area. After the workshops, different organizations, students, and other skilled individuals created more than 20 data visualizations, applications, and research projects using the data captured with the installed audio devices. The list of these projects was collected and made available in the project website as a directory for all interested parties to use or get inspired by. At the end, in order to communicate the value of soundscape data to the broader public over and above the biodiversity community, the team created Sonicabana, a sonic art installation, a long-form soundscape composition that was transformed and shaped by visitor listeners who were invited to move portable loudspeakers around the space. In St. Cecilia Concert Hall, 6 boxes containing a small computer, amplifier, speakers, battery, and a compass sensor were put on wheels. These boxes were playing the sounds recorded in and around the meadows in Edinburgh. As the visitors moved the boxes around, the sound changed. When they discovered positions that they liked, they could sit back, lie down, relax, and wait for others to intervene. The visitors also could explore the open projects created using the captured data. After the project conclusion, the management team had a final touchdown meeting to discuss the key insights and learning from project and made it available to the interested public. The project helped the Living Lab team to reflect on the meanings of community and citizen and on the potential role of new ideas and opportunities at the interface of technology and city issues. They aimed to reach biodiversity, technology, and sound art enthusiasts. They also wanted to engage people using or interacting with meadows who have little or no experience of biodiversity monitoring, sound recording devices, or audio data analysis and presentation. All of these people were in some way community members and citizens of Edinburgh, but the latter group was their ideal target, what was the most difficult to identify, reach out to, and draw in. Valuable insights from the final management team meeting were that 1. It is necessary to take the message out to the community groups where they are already meeting, inform them about the project, and build a relationship with them first to get them to attend workshops. 2. It is easier to attract a lot more interest in the project once there is a larger volume of data from the devices in a form that can be easily shared. Another key insight was that the general public's understanding and acceptance of smart city developments cannot be taken for granted, and projects must demonstrate their trustworthiness in a climate of growing suspicion about data collection and use, especially through systems that appear unusual and opaque. The project showed that citizen engagement and co-production could be crucial ingredients in developing trust. The final case illustrates applications of participatory approaches for urban biodiversity in Guimarães. Guimarães is a city in northern Portugal. It's known for well-preserved medieval buildings and stunning nature. The city was facing an issue with invasive species that threatened the biodiversity and the proper provision of crucial ecosystem services of the city. In addition, the city didn't have a structured database library to keep track of its biodiversity objects. To tackle the challenge, in 2015, the municipality of Gumares implemented the P2 Green project for reforestation and control of invasive species in the green areas of the city. In the project, the city planners decided to adopt a participatory approach to sensitize and educate citizens and local stakeholders by involving them in the process. The municipality believed that the bottom-up approach would result in a more sustainable and long-term impact. The P2 Green project consisted of two main stages. Each stage included different but integrated programs and activities. One, the initial stage of the project, was the diagnostic stage. In this stage, the project team created a mobile app, Biodiversity GO. This was an open-source application and aimed at increasing the capacity to create a biodiversity database of the city by engaging communities. Second, the Invasive Alien Species Plant Control Program was created. The program implemented an initiative in identifying, characterizing, and monitoring invasive plant species. It mapped the presence of invasive alien species and indicated protocols for eradication of those species. The outputs were integrated into the biodiversity database. Third, the environmental education program was developed, in which children from the community were invited to plant trees and protect them during all growth stages. Private companies expressed an interest in the project by buying trees to be planted. The second stage of the project was the valorization and promotion of biodiversity. In this stage, biodiversity routes, such as the routes of Monte Latito Park and Pena Mountain, were created for the conservation of biodiversity in green zones and for making these areas more attractive for locals and tourists, thus promoting natural heritage. The creation of these routes enabled the community, especially the young and the elderly, to learn more about the biodiversity and to share their knowledge about species. Secondly, the Gumares Ornithological Observation Center was created to monitor species while educating and raising awareness of community of the importance of protecting species biodiversity. Thirdly, a social campaign and a series of infrastructure investments were executed aimed at promoting nature tourism. In this, special efforts were put to engage both locals and tourists in the enhancement and co-creation of the database with the use of Biodiversity GO, the mobile app that was developed earlier in the project. Throughout all the stages and steps of the project, inclusivity and public participation were prioritized. The participatory approach of citizen science and open data practices were executed through data collection with the Biodiversity GO. In addition, throughout the process, multiple co-creation training workshops and tree planting activities with kids were organized. The P2 Green project was a success. It was recognized as an URBAC Good Practice in June 2017 and presented at the URBAC City Festival 2017 in Tallinn. The Invasive Alien Species Control Program, together with the Environmental Education Program, allowed private partners and school groups to assist in the reforestation and control of invasive species in the green areas of Gumares. The replacement of these species by native species of the Portuguese forest allowed 15,000 new plants to be planted in green and/or burnt areas of the municipality each year. The creation of species observation centers increased the number of other records made by the community in the biodiversity database of Gumares. It provided assistance to building the inventory of all the biodiversity in the municipality. The P2 Green project helped Gumares and its community better understand and preserve their green areas and biodiversity. It also built on the potential that the area offered to become a point of reference in tourism, not only in the cultural and historical aspects, but also natural. The participatory approach and the process that the city of Gumares adopted for P2 Green project was structured and simple enough to be implemented in any city in order to promote and valorize biodiversity. Breakpoint. 1. Think about the data that is generated in your city, such as from activities of humans and other species, such as movement and interactions, or from natural changes, such as in temperature. List some sources of data. 2. How could this data help city planners or other responsible parties plan for biodiversity conservation? List a few ways. 3. How could the public help access this data or turn them into insights? 4. What technology could be used? Please explore these links for your interest. This module has been developed in the frames of the German-Armenian Network on the Advancement of Public Participation GIS for Ecosystem Services as a Means for Biodiversity Conservation and Sustainable Development, also known as GATES. This program is financed through DAAD, the German Academic Exchange Services, with funds from the German Federal Ministry of Economic Cooperation and Development.